Hello friends, in this lecture we are going to learn about multi-category continuous perceptron algorithm. Now multi-category continuous perceptron algorithm is actually based on multi-layer. Now in the multi-layer concept we have the concept of input layer again, we have the output layer again, but in between we have some layer which are hidden. So these hidden layer are actually again useful for processing computations, and then by taking an input from the input layer, and computation will be performed on the hidden layer, and then this hidden layer will pass the input to the output layer. So after that hidden layer perform the computation, then only the output will be forwarded. So now there are given, according to this algorithm, there are given p training pairs. Now p training pairs are given in the form of y1 into d1. Again the training pairs, like a single category continuous perceptron algorithm, is given in the form of a pair. Like first is the input and second is the desired output. That means you have been always given an input value. Now based on the input value, whatever input has been given, you process that particular input. That means the network will process the particular input and will give you an output by processing it by the hidden layer, and it will give an output. Once it will give an output, that output will be called as an actual output. So actual output will be always compared with the desired output. So that means it is again a kind of a supervised learning. So in supervised learning, always a desired output has been given. Now after this, the values, that means the input values, is always in the form of matrix. So it is a matrix representation of the input form. Desired output, that means only one value has been given to you, as which is always given again in the matrix form. Then by following this algorithm, that these are the initialization steps that you have to do. Then after that we have to go for step number 1. Now what the step number 1 says is that first you have to take a learning constant. Now this learning constant in the single layer perceptron we represent it with the help of a C, but this time we are taking an neta as a constant value. Okay, so you have to multiply it later on, so always choose this value greater than 0. If you take a value which is less than 0 or 0, your answer will be is nothing, or it will go in the negative cycle. Then after that, your Emax value, that is the maximum error, is always greater than 0. We'll assume that network should have an error which has been generated previously, but if you are doing it first time, then like in a single perceptron, you can keep it 0. Okay, then after that you follow the step number 2. In step number 2, weights are initialized at small random values. Whatever the weights we are taking, we always take the weights based on the small random values. There is no predefined categories or criteria for opting the weights. We can take any number of weights, and those weights, if you take the small values, that will be easy for the further calculation. Okay, then after this you have to initialize the training pair. That means you have been given the number of training pairs, 1, 2, 3, 4 and so on. So out of these number of pairs, you have to initially start from something. So that first point is 1. So P is equal to 1 and E is 0 initially. As I told you that initially when we start a cycle, there is no error generated, so we can take this value as a 0 value. Okay, then after that you will go for step number 3. Step number 3 says input is presented and output is computed. Now whenever we present a particular input, and then from that particular input we always want some particular output. Input gives you an output. Okay, so in this case your input will be represented, in this particular case the input is represented by y, and this y is represented by one particular pair. So for example, in the first case y is 1, so you are taking a first input value, and D represented for desired output. So D, for example, if you are comparing this actual output after comparing with desired output, so that desired output is 1 because we are working on the first pair. Then after that your O, that means the actual output which you are comparing, actual output. Okay, so actual output is calculated with the help of multiplying the weight values with the input values. Input is y and weight is w, and then you pass it to the particular thresholding function. Then in step number 4, weights are updated. Now based on the previous values, you have to find out that whether your actual output is equal to the desired output or not. If it is equal to the desired output, then there is no need of weight updation. But if both are not equal, so in that case you have to update the weights. So weight updation formula is again weight, old weight plus half of learning constant, which is represented in the multi-layer concept compared with the single layer concept, is n eta this time d minus o whole square, which is desired output minus actual output, because you have to take care of the error which has been generated by the layer. Then after that you have to multiply it with the O, that means O into half of 1 minus O square into input. Now friends, if you realize this particular part, O into half of 1 minus O square, then in this case, from where we are getting this particular formula is, we are getting this formula by deriving f dash of net of delta learning rule. So if you look at my previous videos, then you realize that from where we are getting this particular formula. Then at step number 5, we are actually computing a cycle error. Cycle error is computed based on d minus o ka whole square plus e. Now d minus o whole square is what? It is actually an error, which is the difference between the desired and the actual one, plus the error which has been generated by the previous layer. If the cycle is just started yet, so we can keep it 0, otherwise we can take the value of that error generated layer. Then after that you have to check, supposingly we have started from 1, and then we have to take out like how many number of pairs have been still pending. So if there are total number of pairs are 3, so 2 number of pairs are still pending after completing this first pair. So you can further go ahead and increase the cycle, otherwise you can go to step number 7, which is the end of the training cycle. Now in this case, you have what the three formulas are very much important for this is actual output computation. Then after that, on the basis of this, you have evaluated the weight values, and based on this weight values evaluation, you further have to evaluate it that what is the error of your particular training number of steps. So these are the 3 formulas which you have to take in care. And how this particular multi-category continuous perceptron is different from the previous single category perceptron algorithm, on the basis of, like in this case, the concept of hidden layer has been added, but in that particular case there is no hidden layer concept added. Thank you.